And we're going to cover one section from Chapter 19. This will also be covered in Chem 1B if you're going to take that class, but it's listed on the course outline for Chem 1A, and so we're supposed to cover it. So we're going to. We'll have proof. And the thing we need to cover is balancing redox reactions. Balancing redox reactions can be kind of tricky, and so there's a separate method for balancing redox reactions. So let's just review. So this is kind of handy, review for the exam next week, on what a redox reaction is. So oil rig helps us to remember that oxidation is loss of electrons, reduction is gain of electrons. So something being reduced is gaining electrons. And if oxidation occurs, reduction has to occur. They have to occur together. Another way to look at it is that oxidation is an increase in oxidation state. Reduction is a decrease or a reduction in oxidation state. So if we look at this example here of calcium metal reacting with water to form calcium hydroxide and hydrogen gas. The oxidation state of calcium here is it's an element, it's 0, and over here it's an ion in this ionic compound. So it's gone from 0 to +2. Its oxidation state has gone up. It's being oxidized. It has lost electrons to go from a 0 charge to a +2 charge. If we look at water, this is where we said we've got the two nonmetals, so it's Fe765. Fluorine, no, hydrogen. So hydrogen gets to be what it wants. And what these nonmetals want is the charge that they would take if they were an ion. So hydrogen as an ion would be H+. So this is +1, and there's two of them, and oxygen has to make up the difference. All the oxidation states for this one have to add up to 0 because it's a neutral molecule. So oxygen ends up being -2. Over here we have the hydroxide ion, and that has an overall charge of -1. And so hydrogen is +1, and the oxygen is still -2. And here we have hydrogen as an element with an oxidation state of 0. So hydrogen went from +1 to 0. That's a reduction in oxidation state, a lowering. It did that by gaining electrons. Did it physically gain electrons? No. And that's why we have oxidation states, is because we can't always look at ionic transfers. But in water, hydrogen is a bit electron deficient because oxygen's more electronegative, it's hogging the electrons. And here, as a molecule, diatomic molecule, the hydrogens are sharing their electrons equally. So here it has more electrons, more electron density. It's not actually gained an electron, though. When we write these equations, the masses have to balance, meaning the number of atoms. You have to have the same number of calcium atoms on each side, but the charges also must balance. Some of these you can balance by inspection, the method we've been using all semester. Others you can't. And so you have to look at the oxidation and the reduction separately. So we break the equation into two half reactions. We balance each of them separately and then put them back together. Any questions yet? Reviewing on oxidation states, free elements have oxidation states of 0. Monatomic ions, the oxidation state is the charge on the ion. If we have a compound, all of the oxidation states have to add up to 0 because the charge on the molecule or formula unit is 0. If we have a neutral molecule, that's 0. If you have a polyatomic ion, the oxidation states add up to the charge on the ion. And then we've got metals are always going to have positive oxidation states in compounds. This really goes back to just the charge on those monatomic ions. And then we've got this guy, which I already mentioned again. FHO765, Fe765. So here's the procedure for what's called the half reaction method. So you assign oxidation states to all the atoms, and you figure out what's being oxidized, what's being reduced. Then you separate into two half reactions, one for the oxidation, one for the reduction. You balance each of those, first with respect to mass. This is for aqueous redox reactions that are happening in acidic solution. We'll look at what happens with a basic solution in a minute. So first of all, balance everything other than hydrogen and oxygen. Then you're going to balance the oxygens by adding water where it's needed. Then you're going to balance the hydrogens by adding H+. Because it's aqueous in acidic solution, so there's plenty of water and acid available, so we can just stick those in there. Then you balance each of them with respect to charge by adding electrons. So the sum of the charges on both sides of the equation has to be equal, and you just put as many electrons as you need in there. Then you're going to make the number of electrons in both half reactions the same. So you may need to multiply one or both of them to get that to happen. Then you add them together. The electrons should cancel out. Some of the other things might cancel out. And then you have to double check. So that's probably like blah, 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 blah. Let's do an example, and maybe it'll become a little clearer. So here in this example, I've put very briefly the steps over here. So we're supposed to balance this redox reaction. We have aluminum, and we have copper ion, and those are reacting, and we're getting aluminum ion and copper metal. If you look at this, it is already balanced in terms of atoms, isn't it? There's one aluminum on each side and one copper on each side. But look at the charges. Over on this side, we have a total of +2 charge, and on this side, we have a +3 charge. How do you balance that? Well, you need to do this half reaction method. So aluminum has an oxidation state of 0, and copper has an oxidation state of 0, because those are the elements. What's the oxidation state of aluminum ion? +3. And what's the oxidation state of copper 2 ion? +2. That's not too hard, is it? So we've got aluminum being oxidized and copper ion being reduced. You don't actually need to identify this one's oxidation, this one's reduction. You just need to be able to separate them. So I tend to like to do the first one first. So I've got aluminum, solid, going to aluminum 3+, aqueous. So that's one half reaction. And then I've got copper 2+, aqueous, going to solid copper, and that's another half reaction. So I separated them. Now I need to balance them with respect to mass. Well, aluminum and aluminum, one of each, so that's already balanced by mass. One copper, already balanced for mass. So I don't have to do anything else there, but I need to make the charges the same. So here I've got a total of 0 charge, and here I have a total of +3 charge. The charge on each side of the arrow needs to add up to be the same number. They're not going to be 0 necessarily, but they have to be the same. And the only thing I can do to balance it is put electrons in there. So if I want +3 to get down to 0, I could add 3 negatively charged electrons, right? So this has a +3 charge. These guys have a -3 charge. They add up to 0. And then down here, this side's 0, and this side's positive. So if I add 2 electrons over there, then the charges on each side of the arrow will be equal. You see that? Oxidation is loss of electrons. Here the aluminum is losing electrons. Reduction is gain of electrons. The copper ion is gaining electrons, so this is the reduction. Where do those electrons go that the aluminum is losing? They go to the copper ion, right? But here, aluminum is losing 3 and copper's only gaining 2. That doesn't work out. So here's where we need to make the numbers of electrons the same. So I've got 3 and I've got 2. I'm looking for the least common multiple, which would be 6. So if I multiply the top equation by 3, No, by 2. Sorry. So I'm going to multiply it by 3, and then that becomes a 6. It's still balanced, right? 2. Yes, I said that, and then I did not do it. Psst. Okay, sorry. 2, 2, and 6. Is it time to go home yet? And what do I need to multiply the bottom one by? 3. That's what I was trying to do on the top before. Okay, still balanced. Now, when we add these two equations together, this top one is giving off 6 electrons. This bottom one is taking 6 electrons. So we're not going to see the electrons in the overall reaction because they were given from the aluminum to the copper ions. So those cancel out. And we write down what's left. We've got 2 aluminums, solid, plus 3 copper ions. Gives us 2 aluminum ions, plus 3 copper atoms. Okay? If you count number of aluminum atoms, number of copper atoms, it's balanced. If you look at the charges now, the charge is the same on both sides. Any questions? Let's do another one. H plus Cr goes to H2 plus Cr2 plus. Let's look at oxidation states. What's the oxidation state of hydrogen ion? +1. What about chromium? 0. What about H2? 0. What about Cr2 plus? +2. Okay, so we have hydrogen going from +1 to 0, that's a reduction, and chromium going from 0 to +2, that's an oxidation. So I'm going to start with the hydrogen ion, and that's going to, I only want to pull out what's related to this. So H plus going to H2. The Cr2 goes in the other half. So I've got H2 gas. And then the other one is involving the chromium. So solid chromium is going to chromium 2 ion. Okay? Any questions? First we balance for mass. So looking at this one, I have 1 hydrogen, and here I've got 2 hydrogens. So I need to put a 2 in front of the hydrogen ions so that the mass is balanced. And the chromium, 1 chromium and 1 chromium, that one's already taken care of. Now I balance the charges. This side is 0, this side is +2. So I need to add 2 electrons over there. 2 negatives, 2 positives add up to 0, and that side's 0. And the second one, I've got a 0 charge here and a +2 there, so I need to add 2 electrons down here as well. Are we okay? You should end up with one of your reactions having electrons as a reactant and the other having electrons as a product, or you're doing something wrong. Okay, now we need to make sure that our numbers of electrons are equal. So the 2 electrons and 2 electrons, we don't have to multiply this one. So the 2 electrons cancel each other out, and I'm just going to write down what's left. H plus aqueous plus Cr solid goes to H2 gas plus Cr2 plus aqueous. Any questions?
Can you go back? Can you say the
How I added the 2 electrons? Yep. So I added the 2 electrons here because after balancing for mass, so that I have the correct number of hydrogen atoms, I need to make sure that the charge on the left side of the arrow and the charge on the right side of the arrow is the same. So the charge on the right side of the arrow is 0. H2 has no charge. And over here, before I stuck those electrons in here, I have 2 hydrogen ions, so a total of +2 charge. I need to get them the same, and the only thing I can do is add negative electrons. So I have to put 2 electrons here, so 2 negatives and 2 positives add up to 0. Down here I've got the 0 on the left and the +2 on the right, so I put the 2 electrons over here. So the charges add up.
You said that the electrons, something they won't cancel out, right?
These electrons will cancel.
But in one condition, one thing.
Well, if you look at this equation up here, the charges are not equal. This is a simple one. You could balance it the regular way. But the one we looked at previously, you can balance it by mass, and then the charges don't add up. So what happens here is this chromium is losing electrons, and the 2 electrons that it loses are gained by the 2 hydrogen ions. And so the electrons don't show up in this equation because they're not a reactant or a product. They were released by the reactants and taken into the products. So they moved, but we don't see them overall.
So it's only when the electrons lost by either one are different that you actually have to multiply by the common.
Right. So if these do not have the same coefficients on the number of electrons, then you have to mess with it. If they come out to be the same like this one did, then you don't have to worry about it. Yeah. Okay, let's do another one. This one's going to be a little more difficult. So, oxidation states. What's the oxidation state of iron 2+? +2. Let's skip the permanganate ion there. How about Fe3+? +3. And how about manganese 2+? +2. Okay, now we got to go back to this guy. Okay, so this is the permanganate ion. It overall has a -1 charge. The oxygen is going to get to be what it wants. What does oxygen like to be? -2. So the oxygen is going to be -2. And then we use that to figure out what the oxidation state for the manganese is. So we've got 4 oxygens. And they're each an oxidation state of -2. So that's a total of -8. And overall, the oxidation states have to add up to -1. So we've got X plus -8 equals -1. What is X? 7. So this manganese is +7. Any questions? It seems like kind of a high number, doesn't it? But manganese does that. Honestly, the directions say to assign the oxidation states, but I think you could probably balance these just fine without it, as long as you can figure out what things to put together. So here I've got 2 reactants. One's going to be in one half reaction, the other's going to be in the other half reaction. So I've got Fe 2+, and I've got the thing related to iron on the other side, so that's the Fe3+. And then I've got MnO4- aqueous and Mn2+ aqueous on the other side. I don't want to put iron 2+ going to manganese 2+ because that's going to be impossible to balance, right? So we balance with respect to mass first. So I've got 1 iron and 1 iron. Oh, okay, that one's done. Here I've got 1 manganese and 1 manganese, but there's oxygens in here. So I need to use water to balance the oxygens. Here I've got 4 oxygen atoms. I need to get 4 oxygen atoms on the other side, so I have to add 4 water molecules. Okay? You can't just throw O2 in there or something. It's an aqueous solution, there's water present. I fixed the oxygens, but now I introduced a new problem, hydrogen. This is an acidic solution, and so we're going to balance with hydrogen ions. So how many hydrogens do I have over here? 8. 4 plus 2 is 6, but we're multiplying. So it's 8. So 8 hydrogen ions. So now it's balanced by mass, looking at the atoms, right? The next step is to balance the charges by adding electrons. So the top one, I've got a +2 on one side and a +3 on the other side. I'm not trying to make them 0. I'm just trying to make them the same. And the only thing I can do is add negative electrons. So if I add 1 electron to this side, +3 and -1, that gives me +2 charge on this side and +2 charge on that side. Down here on the right, I have a +2 charge, and what's the overall charge on the left side? +7. So I have 8 hydrogen ions. That's a total of +8, and I have a -1 here. So that's +7. So I've got +7 over here, and I've got +2 over there. So I'm going to add electrons to this left side to bring it down to +2. How many do I need? 5. So 5 negatives and 8 positives. That's +3. And then a -1 +2. So overall +2 on this side, overall +2 on that side. Questions? What do we need to do next? The number of electrons. So I've got 5 electrons on this half reaction, and I have 1 electron on that half reaction. So I need to multiply the top half reaction by 5. So I get 5 electrons. I have to multiply everything in the equation, otherwise it won't be balanced anymore. Now I have the numbers of electrons the same, so I can add these together and the electrons will cancel out. The order in which you write the reactants or the products doesn't matter. If you want to put hydrogen first and iron last, it doesn't matter. Even mastering chemistry is not going to care. Any questions? Let's do another one. Balance the redox reaction in acidic solution. Well, let's just skip the formal charges. Not the formal charges, the oxidation states, and see if it's still going to work. So I've got copper and copper. So I want to put those together in one half reaction. So I've got copper solid going to copper ion. And then I've got nitrate and nitrogen dioxide. Those both have nitrogen in them, so those are going to be together. Nitrate ion. NO2 gas. Any questions about that? Split it into half reactions. Balance with respect to mass. First one's fine. Second one, the nitrogens are fine, but the oxygens are not. I've got 3 oxygens on the left, 2 on the right. I add water molecules to balance the oxygen. So if I put H2O, bless you, liquid over here, now I have 3 oxygens over here and 3 over there. But I threw hydrogen in, and so I need to take care of that. I have 2 hydrogens over here, and so I need 2 hydrogen ions on the other side. Okay? Next, I have to take care of electrons and balancing the charges. I've got +2 on this side and 0 on that side. If I add 2 electrons over here, I can make both sides 0. And then in the second equation, here I've got a neutral molecule and a neutral molecule, so those are adding up to 0. And what does this side add up to? +1. I need to make it 0, right? So I'll add 1 electron. So put the electrons in there and then double check, right? So I've got a -1 and a -1, that's -2, and +2, 0, and on the right side, 0. So now I have 2 balanced half reactions. I need to make the number of electrons that appear the same. So up here I've got 2 electrons as a product. I need 2 electrons as a reactant down there. So I need to multiply everything here by a 2. So this becomes 4 hydrogen ions and 2 nitrate ions and 2 nitrogen dioxide molecules and 2 water molecules. Then I can add my equations together. Those 2 electrons that are produced get used up, so they don't show up in the final equation. So I have copper solid plus 4 hydrogen ions plus 2 nitrate ions is going to form 2 nitrogen dioxide molecules and 2 water molecules. Any questions? Well, what if it's not an acidic solution? What if it's a basic solution? We're going to do the same process, but we're just going to give an extra step because we don't want H plus in there. So we go through the same balancing with respect to mass. All the other elements besides hydrogen, oxygen, balance oxygen by adding water, balance hydrogen by adding hydrogen ion. And then we need to neutralize the hydrogen ion by adding the same number of hydroxide ions as there are hydrogen ions. Because if you have a hydrogen ion and you put a hydroxide ion, what do they make? Water. So if you have 2 hydrogen ions, put 2 hydroxide ions in. So that's how we're going to get rid of the hydrogen ions. So let's do one of those. Balance the redox reaction in basic solution. We'll divide this into half reactions. So we'll get I minus aqueous going to I2 aqueous. And we'll have permanganate ion aqueous going to MnO2 aqueous. Next step is to balance with respect to mass. So the top one, we need a 2 in front of the iodide. So we've got 2 iodine atoms on each side. On the bottom, we've got 1 manganese and 1 manganese. We always do the non-oxygen hydrogen ones first. And then we have to look at the oxygens. Here I have 4 oxygens and 2 oxygens. How do I fix that? Add water. So I'm going to add 2 water molecules to the right side. So now I've got 4 oxygens and 4 oxygens. And then I've introduced hydrogen. So I've got 4 hydrogens there. So on this side, I'm going to add 4 hydrogen ions. It's the same so far. Basic solution, what I'm going to do now is I'm going to look at my hydrogen ions here. I've got 4 hydrogen ions. That tells me I need to add 4 hydroxide ions. I have to add that to each side or it's not going to be balanced.
How do you know that it is basic or acid?
The question will tell you. So this one says in basic solution. Otherwise you wouldn't know. Well, 4 hydroxides and 4 hydrogen ions, what does that make? 4 water molecules, right? So 4 H2O, liquid. I like to combine those because it makes counting up the charges easier. You could also cancel out the waters if you want, because there's 2 waters over here and there's 4 over there. You want to simplify that right now? This means yes. This means no. Okay, I saw somebody nod. So 4 waters here and 2 waters there. So if I get rid of the 2 waters here and change this to a 2, it's still balanced. And go ahead, let's check. So on this side now I've got 4 hydrogens, and over here I have 4 hydrogens. Here I have 4 plus 2 is 6 oxygens, and I have 2 plus 4 is 6 oxygens, and the manganeses are still the same. Everybody okay with that? This has gotten messy, so I'm just going to clean it up a little bit. Now I need to take care of the charges. So in the top here I've got 2 negative on the left and 0 on the right, so I need to put 2 electrons in here. And I'm going to bring this guy in. He's going to get lost. In the second half reaction, on the left side I have a total of -1 charge, and on the right side I have -4 charge. I need to make this one be the same, so I need to add 3 electrons. Okay? What's the next thing I have to do? I need to get the same number of electrons. I've got 3 electrons down here and 2 up there. So the smallest number I can do is 6. So I need to get 6 on the top and 6 on the bottom. So I multiply the top by 3. 2 times 3 is 6. And this is going to be 3. And this will be 6. And then the bottom, I'm going to mumble about. The bottom I'm going to multiply by 2. So 2 times 3 is 6. 2 times 2 is 4. 2 times 1 is 2. 2 times 1 is 2. And 2 times 4 is 8. Now I can add them together. So 6 electrons and 6 electrons, those guys cancel out. Write down what's left. 6 iodide aqueous plus 4 H2O liquid plus 2 permanganate ions gives us 3 I2 aqueous plus 2 MnO2 aqueous plus 8 hydroxide ions. Any questions? Isn't that fun? Maybe not? Oh, what the heck? Let's do one more. I'm having fun. So let's balance this one in basic solution. 2 half reactions. What goes with the ClO minus? So I've got ClO minus on this side. Which of those is going to be on the other side of the half reaction? The chloride. So I've got ClO minus, and on this side I'm going to have chloride. And so I used this guy and that guy, and I've got these 2 left. This has chromium and that has chromiums. We're looking at the things other than hydrogen and oxygen, because we can always add water and hydrogen ion and stuff in there. So we've got that guy, and we've got this guy. Balance by mass first. Elements other than oxygen and hydrogen. So here I've got 1 chlorine and 1 chlorine. Cool. Here I've got 1 oxygen. So that means I have to put water over here. So my oxygen's balanced. And then I have to balance the hydrogens. So I put 2H plus over there, because that'll give me 2 hydrogens, and I've got 2 hydrogens over here. But this is basic solution. So 2 hydrogen ions, that means I'm going to add 2 hydroxide ions to both sides. I think it makes the rest of it simpler if you combine some things right now. So 2 hydroxides and 2 hydrogen ions makes 2 water molecules. So I'm going to write that in there instead. And I've got 2 water molecules on this side and 1 on that side. And so I could simplify that by making it be 1 on this side and none on the other side. Okay? And I'm going to bring this guy over because he gets lost over there. 2OH minus. Really? That one's pulling his hair out, and the other one's got his hat down over his eyes, and the girls across the bench are just giggling like nobody's business. I'm glad you guys are having fun. Okay. So we've got it balanced by mass. What do we need to do to balance it for charges? Larry, what should we do to balance this?
I don't have my glasses today. Gibberish. It is a blur.
That would explain why you're You're
Yeah.
facing away from the screen
Yeah, that's,
because the view is nicer over there, right?
it's more clear.
Yeah, he's looking at the girls. Good grief. Okay. That is high school kids. So total of -3 on that side, only -1 on this side, 2 electrons. Okay, that guy's done. Now we've got 4 oxygen, well the chromiums are good, 4 oxygens and 4 oxygens. We just have hydrogens as a problem. So here we have 4 hydrogens and no hydrogens. So we need 4 hydrogen ions to balance the hydrogens. But this is basic solution. So we're going to add 4 hydroxide ions to both sides. Four hydrogen ions plus 4 hydroxide ions is 4 water molecules. So we've got the mass is balanced. We need to balance charges. Here I've got 4 negatives and 1 more negative. That's a total of -5 on that side. I've only got -2 on this side. So how many electrons do I need? 3. And great, we've got the 2-3 thing going on again. So we need to multiply one or both equations so that we get the same number of electrons in both. So I've got 2 in one and 3 in the other. I'm going to go for 6. And so I'm going to multiply the top equation by 3. I have to multiply all the coefficients by 3. In the bottom, I'm going to multiply by 6. No, I'm getting 6. I'm going to multiply by 2. So 2 and 2 and 8 and 6. I've got 6 electrons, 6 electrons. Those cancel out, and then I just copy down what's left. 3 H2O liquid plus 3 hypochlorite ions plus 8 hydroxide ions plus 2, I'll spare you the name of that guy. And then I can already tell I'm not going to have enough room for the other side, so I'm going to just come down here. I've got 3 chloride ions and 6 hydroxide ions and 2 chromate ions and 8 water molecules. Was that good, or do we need to mess with that a little bit more? I've got hydroxides on both sides. We want to clean this up and make it as simple as possible. I've got 8 hydroxides over here, and it's making 6 hydroxides. So I can just take 6 hydroxides out of there. So let's get rid of those. And then this goes from 8. I removed 6 of them. I just need 2. And then always check it at the end to make sure the charge is balanced and the mass is balanced. Any questions? It's just tedious, is what it is.